moving on to our next sequence, that is a geometric sequence. A geometric sequence kind of goes along with the arithmetic sequence, except instead of adding the same thing to get to the next term, a geometric sequence is where you multiply by the same thing to get to the next term. The mathy definition is a sequence where each term is a constant multiple of the previous term. And that constant multiple is what we will refer to as the common ratio. So that is what you multiply by. So in an arithmetic sequence, you have a common difference. In a geometric sequence, you have a common ratio. And you get the common ratio by dividing any two consecutive terms. So what I have here is three geometric sequences, and we're going to find the common ratio. And again, the common ratio is simply what you multiply by to get from one term to the next. Now, number one here is pretty easy. To go from 1 to 3, we multiply by 3. To get from 3 to 9, we are multiplying by 3. From 9 to 27, we are multiplying by 3. And whatever number it is that you're multiplying by is your common ratio. So for number 1, your ratio is 3. And that one's pretty easy to see, hopefully. Number 2, however, is not as easy because 3 times something decimally is going to be 3/4. So the way we get our common ratio in this case is you simply take any two consecutive terms and you divide them. So I will simply I'm going to take 3 and 4 because they're nice numbers. And your common ratio is going to be, you always do the second one divided by the first one. So my common ratio is going to be 4 divided by 3. And that doesn't reduce, so there's your common ratio. I'm going to do the same thing for number 3. Take any two consecutive terms. It doesn't matter which two you choose. And you divide them. So the common ratio for number 3 here is going to be 10 divided by negative 20, which is negative 1/2. So there's your common ratio for number 3. By the way, number 3 is called an alternating sequence. And alternating just means the signs change with each term. I have a positive, then a negative, then a positive, then a negative, then a positive. That is what you call an alternating sequence. So if I ever mention an alternating sequence, that's what I'm talking about. Then we have explicit formulas for geometric sequences. And the explicit formula is simply the formula you use to get each successive term. And in a geometric sequence, your formula is simply a sub n equals your first term times the ratio to the n minus 1 power. That is an exponent up there. So all we need to do is find the first term and the common ratio, and we plug it into the formula. So let's use this formula on these examples, and I'll write it again up here in the corner. A sub n equals your first term times the ratio to the n minus 1. And so to get my formula, what I have to do is find my first term, which isn't too hard. You just look at the first term. Hey, found it. There it is. A sub 1 is 6. And my ratio, we're going to get the ratio, like we did on those last problems, simply take any two consecutive terms and divide them. In this case, my first two terms are 6 and 9. When I do 9 divided by 6, that reduces to 3/2. And then once you have your first term and the ratio, your explicit formula, which I referred to yesterday as a general formula, but the explicit formula is your first term times the ratio, which is 3/2, all to the n minus 1 power. There you go. Same thing for number 5. My first term is negative 1/6, and my ratio, this one's going to be a little bit trickier, but you take any two consecutive terms, which I'll choose 1/3 and negative 1/6, and you divide them. Remember, when you divide by fractions, you multiply by the reciprocal. So I'll multiply by negative 6 over 1. 3 goes into negative 6. 3 goes into 6 two times, but that was a negative. So my ratio here is going to be negative 2. So now that I have my first term and I have my ratio, my formula is my first term times my ratio to the n minus 1 power. There we go. So there's a geometric explicit formula. Was there another one? Nope, that was it. All right, a couple of other formulas for geometric sequences. If you want to find the nth term, like if I ask you for the 14th term or something like that, you use the exact same formula we just used. The nth term is your first term times the ratio to the n minus 1. So that's not new. That's the same formula we just used on these two examples. However, the sum of the first n terms, if I want you to add up the first 14 terms, then we use this formula, and this is very calculator intensive. You have to be extremely careful with your parentheses because it just can be a little bit of a pain. So let's find the desired term of these geometric sequences. I want the ninth term, so I want you to find a sub 9 of this sequence, and so I need to first find the formula. I know my first term is 1, and my ratio, take any two consecutive terms. Oh, interesting. Any two consecutive terms, and you divide them, and I have a problem here. Because if you divide 5 and 1, you get a ratio of 5. However, if you choose 5 and 10, and you divide those, you get a ratio of 2. So this is actually not geometric, so we cannot use the formula. So this is not geometric. That was a typo. I meant for that to be, what's 5 times 5? 25. I don't know what I was thinking here. Therefore, this is not geometric, which means we cannot use the formula, and we actually can't answer this question. So we'll just stop. It's not a geometric sequence. We're not going to find the formula. So we just stop. This one's actually not geometric. We first multiply by 5, and then we multiply by 2. So that's not geometric, and we just stop. Can't do anything with it. The seventh term, a sub 7, given this. My first term is 3. My ratio, take any two consecutive terms. And I think I botched this one too. Holy cow, you know what? I'm going to fix this because I'm not going to have two mess ups at once. I'm such a loser. There we go, fixed it. All right, so to get my ratio, you simply take any two consecutive terms and you divide them. I will choose -2 and 3 because those are easier. And -2 divided by 3 does not clean up. So I will take that, and my general formula ends up being my nth term is my first term times the ratio to the n minus 1 power. And then now that I have the nth term, I want to find the seventh term. So my seventh term is going to be 3 times -2/3 to the 7 minus 1 power. And I'm pretty good at math. I'm going to change that to -2/3 to the 6 power, because 7 minus 1 is 6. Right. Make sure when you punch this in, you follow your order of operations. Exponents must be done before multiplication, so make sure you do that first, and we will punch this in the calculator. And we get an answer of, let's see here. We get 64 over 729. The final answer is 64 over 729. So when you're punching these in, make sure you do follow your order of operations. Do the exponent first and then multiply by 3. Or just throw it all into the calculator at the same time. And you know what? I messed up. That is not the correct answer. I forgot to multiply by 3. All I did is the exponent. When you multiply that by 3, you get 64 over 243. So let me fix that. Hey, stop that. 64 over 243. There we go. So you do make sure you do the exponent first and then multiply by 3 afterwards. All right, the partial sum. These are where you use that really ugly formula where the sum of the first n terms is your first term times 1 minus the ratio to the n power over 1 minus the ratio. And so what we need here is n is how many terms there are. So 8 terms. That means we're going to let n equal 8. My first term is 8. A sub 1 is 8. And my ratio, we need to find the ratio, and we get the ratio by dividing any two consecutive terms. So my ratio is going to be 14 divided by 8, which reduces to 7 over 4. So there's my ratio. Then we simply take all of that and plug it into the formula. The sum of my first 8 terms is going to be my first term times 1 minus my ratio, which is 7/4, all to the n power, but n is 8. We're looking for the 8th partial sum over 1 minus my ratio. And this is another case where you want to be extremely careful with your parentheses when you punch this in the calculator. And you want to make sure that you group the numerator in one big set of parentheses, group the denominator in one big set of parentheses, and punch it in. Now the beauty of the TI-89 is that if you do it all in one big swoop, it will put things in what it refers to as pretty print, and it's pretty easy to tell if you punch it in right. So let me do this. And here what I was is what I was just talking about in regards to the TI-89. It's kind of dark. Hopefully you can read that. Your answer ends up being 1,899,755. Hey, 755. That's how many home runs Hank Aaron hit over 2,048. That ends up being your answer. And the TI-89 is nice because when I punched it in the first time, I actually messed up and I accidentally hit 1 divided by instead of 1 minus 7/4 to the 8th. And it showed me that in the calculator. So that's the beauty of the TI-89. So I knew my first answer was wrong. And so I just fixed that and hit enter again, and there's your answer. So there's the partial sum of that one. Let's try this one. Now this one is in the sigma notation. Remember, you want to know how many terms there are. You need to know what the first term is and what the ratio is. And the way I like to do that is I'll simply plug in my first two terms. If I plug in 1 for n, that's 8 times 1/3 to the 1 minus 1. My second term is going to be 8 times 1/3 to the 2 minus 1. And when you clean that up, 8 times 1/3 to the 0 power plus 8 times 1/3 to the 1th power. 1/3 to the 0 is 1, so 8 times 1 plus 8 times 1/3. And that gives you your first two terms of 8 and 8/3. The reason I wanted the first two terms is because now I can easily tell that my first term is 8, and I need the second term to find the ratio. And to get the ratio, you simply divide any two consecutive terms, so 8/3 divided by 8. And when you divide with fractions, you multiply by the reciprocal, so that's 8/3 times 1/8. The 8's cancel, leaving you with 1/3. And some of y'all watching may be saying you didn't really have to do all that because remember the general formula is your first term times the ratio to the n minus 1 power. There's the ratio. The ratio is 1/3. So we do have the first term, we do have the ratio. And then if you start at 1 and go all the way up to 12. So I would continue plugging in things and I would stop when I plug in 12 for n. If you start at 1 and count all the way to 12, there are 12 terms, which means n is equal to 12. And then I would throw all of this into that big ugly formula. The sum of the first 12 terms is going to be my first term times 1 minus my ratio to the 12th power over 1 minus the ratio. And then I'll throw that in the calculator. And there we go. You get another massive number, 2,125,760 divided by 177,147. So there you go. That is the ugliest formula that we're going to use with geometric sequences. There is one last formula, and that deals with something called an infinite geometric sequence. And the infinite geometric sequence is simply one that never ends. You don't have only 12 terms. You have an infinite number of terms, and it goes on forever and ever and ever and ever and ever. Well, it turns out that even if the series never ends, if you are always adding numbers to the end of the day, then the way you actually find the sum of all of those terms is this nice clean formula, your first term over 1 minus the ratio, but only if your absolute value of the ratio is less than 1, which is the same thing as saying your ratio is somewhere between -1 and 1. So you can only find the sum of an infinite series if it's a geometric series and the ratio is less than 1. The absolute value of the ratio is less than 1. So let's do a couple of those real quick, and then we'll call it a day. I want you to find the sum of the following infinite geometric sequences, and the formula is, the sum is your first term over 1 minus the ratio. So I need the first term, which is pretty easy. That's just 9 for this case. My ratio, take any two consecutive terms and divide them. So I'll do 8/9 divided by 9, which is the same as 8 over 9 divided by 9 is times 1 over 9. Did I mess up again? I did mess up again. Holy cow. See, I made up these problems very quickly. And I apparently didn't double check myself because this actually ends up not being geometric either. So hang on, what should I do? Should I fix this? I guess I'll fix it. No, you know what? This is just going to happen sometimes. I'm such a loser. Why am I such a loser? I don't know. All right, so the ratio, if you choose the first two terms, is 8 over 81, but the ratio with the second two terms, so this is with the first two terms, um, I'll say a sub 1 and a sub 2, but the ratio with a sub 2 and a sub 3, if you look at this one, you will do your second term 64 over 81 divided by 8/9. And when you multiply that by the reciprocal, 64 over 81 times 9 over 8, these cancel. See, 9 goes into 81 9 times. 8 goes into 64 8 times. And you're simply left with a ratio of 8/9, which is what I intended the ratio to be. But again, I botched it. My ratios are different. They are not the same. Your ratio should be the same. Therefore, this is not geometric. And therefore, we cannot answer this problem. So this thing is not geometric. All right, so let's do 11, and this one should work, and then we'll be done. This one, I would do kind of like what I did the first time. I would write out the first two terms. That's going to be 2 times negative 1/3 to the, now notice here I'm starting with 1, if n equals 1, so it would be to the first power. My second term is going to be 2 times negative 1/3 squared, and then it would continue. Let's see, negative 1/3 to the first, that's just negative 1/3, plus 2 negative 1/3 squared. Negative 1 squared is 1, 3 squared is 9. 2 times negative 1/3 is negative 2/3, plus 2 times 1/9 is 2/9. It will go on forever. And then I can see that my first term is negative 2/3, and my ratio, you will simply divide those. That's 2/9 divided by negative 2/3. You will flip and multiply. 2/9 times 3 over negative 2. Let's simplify that. 2 cancels negative 2 to leave negative 1. 3 goes into 9 3 times, and that leaves you with 1 over negative 3 for the ratio. And then once you have your first term and the ratio, the sum is your first term over 1 minus the ratio, which is negative 1/3. And then we'll throw that in the calculator. And our final answer is negative 1/2. So there's the sum of this infinite geometric sequence, which you can only do if your ratio is less than 1, which this one is. It's between, it's negative 1/3. So there we go. And I think that's it. If there were more problems, I was just going to stop. There aren't any more, and we're done. Long video.